In the mid-1930s, the U.S. Army Air Corps issued a requirement for a new, long-range heavy bomber. The response was the Model 299 prototype, a massive four-engine aircraft that would lay the groundwork for modern American strategic air power. By the time the United States entered World War II, military planners had committed to a highly specific and dangerous doctrine for these bombers: unescorted, high-altitude, daylight strategic bombing missions over Europe. While Britain's Royal Air Force primarily conducted raids under the cover of darkness to minimize losses, the Americans insisted on operating during the day. They relied on the advanced Norden bombsight, an instrument that required clear visibility to achieve precision targeting. The primary targets of this campaign were the industrial organs of the German war machine, reducing ruined urban infrastructure into rubble to systematically destroy factories, transportation hubs, and overall production capacity. Precision bombing was a sound theory for winning a war of attrition. However, the exact same clear skies and visibility required to hit those targets left American bomber crews entirely exposed to enemy defenses. Pushing into hostile airspace, these daylight missions operated on an immense scale, sometimes launching armadas of up to 1,000 aircraft at a time into the skies over occupied Europe. The fatal flaw of this operational doctrine quickly became apparent. Operating in broad daylight allowed the Luftwaffe to easily spot, track, and relentlessly intercept the incoming bomber streams. German pilots flying interceptors, like these Messerschmitt Bf-109s, quickly identified a blind spot in the early B-17 models and began coordinating aggressive head-on attacks. Approaching from the front left the bombers with minimal defensive crossfire to protect themselves. These frontal assaults directly targeted the cockpit and forward fuselage, inflicting severe casualties and heavy aircraft losses on the 8th Air Force. To maintain the daylight bombing campaign without collapsing under the casualty rate, the aircraft required a radical defensive overhaul. It had to become a literal, self-defending flying fortress. Engineers responded with a series of iterative upgrades. The B-17F model introduced a one-piece plexiglass nose, which significantly improved forward visibility for the bombardier and navigator to spot incoming fighters. But the definitive answer to the Luftwaffe's tactics arrived with the final and most heavily produced variant, the B-17G. The most critical addition was the power-operated Bendix chin turret, housing twin heavy machine guns directly beneath the nose to meet head-on assaults. This upgrade brought the B-17G's total defensive armament to 13 machine guns, distributed across the nose, top, belly, waist, and tail. By flying in tight, staggered formations, crews combined this weaponry, creating overlapping, interlocking fields of fire that blanketed the airspace in armor-piercing rounds. This dense network of defensive armament allowed the B-17 to fight its way deep into contested territory, strike its target, and battle its way home. The defensive upgrades were paired with mechanical improvements, notably General Electric B-2 turbochargers. These allowed the massive radial engines to maintain optimal speed and performance at high altitudes, making interception physically demanding for enemy fighters. This chart shows the immense statistical impact of these engineering upgrades on the European theater. Of the approximately 1.5 million tons of bombs dropped on Nazi Germany and its occupied territories by Allied forces, over 640,000 tons, or nearly 43%, were delivered by B-17s. While heady armaments allowed bombers to press the offensive, the sheer volume of anti-aircraft flak and enemy interceptors guaranteed planes would take catastrophic damage. When firepower failed to deter a hit, survival came down to raw structural integrity. On the clear winter morning of February 1, 1943, bombers from the 414th Bombardment Squadron launched a strike against the German-controlled seaport of Bizerte in Tunisia. Flying within that formation was a B-17F named the All-American, commanded by Lieutenant Kendrick R. Bragg and carrying a crew of 10 men. After successfully releasing their payload over the target, the formation turned for their base in Algeria and was immediately swarmed by German interceptors. During the firefight, a damaged, out-of-control Bf-109 rolled inverted over the top of the All-American and collided directly with the bomber in midair. The sheer kinetic energy of a multi-ton fighter striking a heavy bomber at combat speeds should have instantly severed the airframe, sending the aircraft into an uncontrollable and fatal plunge to the earth. The fighter's wing sliced entirely through the upper rear fuselage. It completely sheared away the left horizontal stabilizer and elevator, carving a massive diagonal gash right through the tail section. The impact severed the oxygen, electrical, and radio systems. The entire rear of the aircraft, including the tail gunner station, was left clinging to the rest of the plane by a few bent longerons and a narrow ribbon of aluminum skin. Miraculously, not a single crew member was injured. Realizing the shivering tail could snap off at any second, Lieutenant Bragg and his crew fought the compromised controls to keep the crippled aircraft stable for a grueling 300-mile flight back to base. Defying the laws of aerodynamics, the All-Americans safely touched down in the North African dirt, securing the survival of all 10 men aboard. The legacy of the Flying Fortress lies in precisely this structural endurance. Its true value in the air campaign was measured by an engineering ruggedness that could absorb the absolute worst of warfare, hold together, and bring its crews home.
Before we continue with this video, please like and subscribe as it really helps the channel.
December 1943. 8-mile-long streams of Allied heavy bombers push high above the European continent, carving condensation trails into the freezing air. Among them is a B-17F known as Ye Olde Pub. At the controls is rookie pilot Charlie Brown, tasked with delivering a payload onto a Focke-Wulf aircraft factory in the German city of Bremen. Anti-aircraft flak connects with the bomber during the run, shredding the nose cone and tearing away half of the rudder. Multiple engines begin to fail. Dropping out of formation, the crippled aircraft becomes a solitary target. A dozen Bf-109 and FW-190 fighters quickly swarm the straggler, raking the fuselage with machine gun fire. Inside, the internal oxygen and hydraulic systems are completely gone. The crew is bleeding, exposed to negative 60 degrees Celsius temperatures. In the rear of the aircraft, tail gunner Hugh Eckenrode is dead. The B-17 was designed with significant structural redundancy, but with a severed rudder and failing engines, this airframe was operating at the absolute edge of its survivability. Luftwaffe ace Franz Stigler intercepts the crippled bomber. He needs one final kill to earn the Knight's Cross, and he has a clear line of sight on the battered airframe. Instead of firing, Stigler pulls his fighter plane alongside the B-17, looking through the gaping holes in the aluminum skin. He sees a frantic, helpless crew desperately trying to tend to their wounded. He lowers his weapons. Stigler escorts the American bomber over the North Sea, safely past the German anti-aircraft batteries on the coast, salutes Charlie Brown, and turns back. 80 years later, the few remaining B-17s face an adversary that cannot be reasoned with, or moved by compassion. The threat today is entirely mechanical. In 2021, the Federal Aviation Administration issued an airworthiness directive, immediately grounding the global fleet of surviving flying fortresses. The machines engineered to absorb the most punishing aerial combat of the 20th century are slowly succumbing to time. This diagram shows the B-17 inner wing structure. It connects to the fuselage via 4 primary spar tubes. During inspection, crews found a complete separation of the left front spar lower fitting,
shifting the entire wing 2 inches away from its mounts. The culprit is intergranular corrosion. This microscopic decay eats away at the boundaries of metal crystals, destroying structural integrity from the inside out, particularly near the steel attachment fittings. Detecting this requires specialized procedures. The FAA mandated strict magnetic particle testing for the steel fittings and eddy current inspections inside the bolt holes to find microscopic cracks before they propagate. Addressing this requires a complete disassembly of the wing's load-bearing trusses to replace the primary skeleton of the aircraft. Restoration teams must manufacture brand-new 26-foot-long tapered aluminum extrusions to match the original internal spars. Boeing drafted the original specifications for these tubes in the 1930s. The massive factory infrastructure built to mass-produce them was dismantled shortly after 1945. The Mid-America Flight Museum initiated a global search, ultimately forming a 2-year partnership with a British aerospace supplier to design and build custom heavy tooling capable of forging the massive new aluminum spars. At the Warbird shop in Madras, Oregon, technicians are building custom alignment jigs to ensure the new parts fit perfectly into the 70-year-old structures. Restoring the B-17, known as We the People, requires mechanics to carefully drill out hundreds of original rivets, remove the corroded tubes, and splice the newly manufactured spar components directly into the inner wings. Keeping these bombers airworthy requires modern engineers to replicate the complex industrial manufacturing of the Second World War on a custom, individual scale. The strategy is working. 8 newly certified spar tubes have arrived in Oregon, establishing a tested engineering blueprint to repair the grounded fleet. Other surviving airframes, like the B-17 Yankee Lady, are already undergoing structural evaluation at the Madras facility to utilize this exact repair pipeline. If the reassembly proceeds on schedule, We the People will return to the skies within 2 years. 50 years after their encounter over the North Sea, Charlie Brown and Franz Stigler successfully tracked each other down. They remained close friends until they both passed away in 2008. Their shared history is tied to the physical aircraft. Restoring the airframe ensures that the setting where their encounter took place remains a tangible part of the historical record. The grueling years of reverse engineering are a direct investment in that history. By rebuilding the skeleton of the Flying Fortress, these crews ensure the stories of the men who flew them are never permanently grounded.